Hello guys, and today we're going to be talking about disc clutches. Oh shit. Alright, so we're going to go on and actually understand the clutch. So here we see a friction lining material. We see our driving shaft, our driven shaft, our provisions for axial movement, our ring element subjected to clamping pressure, our clutch disc on this diagram, our pressure plate, spring cover, release bearing housing to transmission to release lever, engine crankshaft, friction planes, and the flywheel. And this figure shows a simple disc clutch with one driving and one driven surface. And driving friction between the two develops when they are forced together. And ultimately, you want the clutch to be forced together in order to separate the transmission from the moving engine. And this is due to gear changes. And during a gear change, you really do want the smoothest conditions. And this can only be achieved when the transmission is at a standstill and not being affected by the forces of the engine. And for this reason, we must use clutches. So here's an actual clutch that you would find on a manual car. So as you can see, we have our flywheel, we have our clutch disc. So what ends up happening is the clutch disc and flywheel are the ones that are making the contact, and this ultimately separates the two engine and transmission from each other. Next up, we have the locating studs, which attach to the diaphragm spring to cover yet allow the spring to flex. So that's a great explanation of what those locating studs do. And next up, we have the pressure plate, which basically applies the pressure to the clutch disc when it's engaged. We have the fulcrum rings. Then we have the diaphragm spring, which is another element to the contact between that clutch and the flywheel. Then we have the clutch cover, which basically just holds everything together. We have the throw-up bearing, which is what pushes everything in. And then we have the release fork, which applies that force to the throw-up bearing. So here are some of the clutch operating conditions. So clutches can be used in wet and dry conditions. Dry clutches are usually found in manual transmissions, and wet clutches can be found in automatic transmissions. And in automatic transmissions, they're usually just coated in automatic transmission fluid, and this actually helps to increase the coefficient of friction between the clutches in order for proper engagement. And what ends up happening sometimes is when this transmission fluid starts to wear out and not work as intended, you'll actually find your Autotrans slipping because it's not producing that friction it used to with that recommended fluid and the appropriate wear level of that said fluid. So we're going to be understanding the forces of the clutch now, and we have three equations here, and I'll just read out what each variable here means. We have the total normal force acting on the area of contact, that's F, the uniform level of interface pressure, that's P, the total friction torque that can be developed over the entire interface, that's T, uh, and then R is the radius of the friction surface, N is the number of friction interfaces, an even number, and F is the friction coefficient. So basically, the friction torque is can be found using those two equations over there, and just for the total normal force, it's the top one over there. And keep in mind these three equations are for a ideal clutch. We're going to be looking in the next slide of how we would analyze a worn clutch. So here are the factors for worn clutches. Uh, so we have PR equals to C, which is equal to P max. Then we have F is equal to 2 pi P max times Ri times Ro minus Ri. Then we have T is equal to pi P max Ri times the coefficient of friction times Ro squared minus Ri squared times N. Then we have T is equal to the force times the coefficient of friction times Rho plus Ri the over 2 times N. And yeah, those are basically the equations that we would use in order to analyze this warm clutch. And just some little bit of clarification here just to see what everything means. P max, it was not mentioned in the previous slide, but P max is the greatest pressure which occurs at the inner radius of the whole assembly. Then we have C, which is a constant in the scenario of these equations. And next up we have Ri, which measures the inner and outer radiuses. Ri is inner, Ro is outer. And that's pretty much everything. If you have any questions, please let me know. But that's the end of this presentation. I hope you enjoyed, and I hope you learned something new today. Thank you.